Namaste students, welcome to statistics class. Today we will discuss the fourth distribution, that is hypergeometric distribution. Until now we are discussing about theoretical distribution. Then firstly we discussed Bernoulli distribution, then we discussed binomial distribution, then we discussed until last class we were discussing about Poisson distribution, and today we discuss hypergeometric distribution. It is the next distribution, that is hypergeometric distribution. And what is hypergeometric distribution? Here I will write the definition. Now, if x is a discrete random variable, with probability mass function what is the function? P of x is equal to ACX, here ACX BC n minus x, BC n minus x divided by a plus b c n. This is the function of hypergeometric distribution, where x is equal to 0, 1, 2 till minimum, open the bracket, a comma n. Minimum in the sense a and n, which will be minimum, that is the range that we will see when we discuss about the features. Then a, b and n is greater than 0, then x is a hypergeometric variate and distribution of x is called hypergeometric distribution. Distribution. So this is the definition of hypergeometric distribution. The same definition, only here this function changes. If x is a discrete random variable with probability mass function p of x, ACX into BC n minus x divided by a plus b c n, where x is equal to range 0, 1, 2 till minimum, which will be minimum. If a is minimum, that is the range, or if n is the minimum, that is the range. Among a and n, which will be minimum, that is the range. Here a, b, n is greater than 0, then x is a, if this is the condition, x is a hypergeometric variate and distribution of x is called hypergeometric distribution. Now here we have the four distributions, that is starting from Bernoulli distribution, binomial distribution, hypergeometric and Poisson distribution. These four distributions are discrete probability distribution. Then three more comes, that is continuous probability distribution. Where we see discrete probability distribution, it starts with if x is a discrete random variable. Then in case of continuous probability distribution, we have to start the sentence with if x is a continuous random variable. So definition, you can by heart the definition other than these functions. Now we will see what are the, now here in case of hypergeometric distribution, here a, b and n, these are integers, and here n is always less than or equal to a plus b. What is the total of a plus b? From that it will be n is always lesser than a plus b. These two are the conditions here. A, b and n are positive integers, and n is always less than or equal to a plus b. It is not more than a plus b. For example, if a is 3 and b is 2, what is the total of a plus b? A plus b is 5. N is, for example, it can be 3 or 2. So n is always lesser than a plus b. Now we will discuss about, there are some features. What are those features of hypergeometric distribution? Now there comes the first feature. Always here comes the first feature. What are the parameters? Here what can be the parameters? Here in case of hypergeometric distribution, the parameters are A, B and N. Here A, B and N, these are the parameters of hypergeometric distribution. Then what is the range of hypergeometric distribution? The range of hypergeometric distribution is x is equal to 0, 1, 2, minimum a comma n. This is the range. What is it? For example, in a particular problem, a is 3 and a is 3, n is 4 days. So in these two, this is a and this is n, which is minimum? 3 is minimum. So what is the range in that particular problem? Range is 0, 1, 2, 3. Among a and n, which will be minimum, that is the range of particular problem. For example, in another problem, a is 4 and n is 2. What will be the range in this particular problem? Which is minimum? Minimum is 2. So here range will be 2. So among a and n, which will be minimum? That is the range of hypergeometric distribution. And next one here, the third feature comes the probability mass function. Your probability mass function is P of x is equal to ACx BC n minus x divided by a plus b c n. As I said, where x is equal to 0, 1, 2, minimum a comma n. This is the probability mass function of hypergeometric distribution. Please study this formula properly. This function you have to study properly. Next comes the fourth one. In hypergeometric distribution, what is mean? Mean is equal to, see the formulas, mean is equal to NA divided by A plus B. This is the mean, and variance is equal to, see properly, NAB, variance is equal to NAB, open the bracket, A plus B minus N divided by A plus B whole square into A plus B minus 1. This is the variance of hypergeometric distribution. What is the standard deviation then? Standard deviation is equal to same root of variance, that is NAB into A plus B minus N divided by A plus B whole square into A plus B minus 1, the root. That is the standard deviation. See here, formula for mean variance is different than other distribution. This is the mean. Mean is equal to NA by A plus B. Variance is equal to NAB into A plus B minus N divided by A plus B whole square into A plus B minus 1. This is the variance. And root of variance is called standard deviation. It is very important here. Mean and variance and standard deviation formula is very important in case of hypergeometric distribution. Then one more, the last feature that I erase it here. The last feature, fifth one, hypergeometric distribution tends to, it can be treated as binomial distribution. Which condition? It can be treated as binomial distribution where A plus B is moved towards infinity. That means A plus B is a, when we total A plus B, that number, when it's a large number, that it means when it moves towards, when it's a bigger number, A plus B, that when the sum of A plus B, when it's a bigger number, we can treat this as a binomial distribution rather than hypergeometric distribution. So this is about the features and the function of hypergeometric distribution. Mainly here the parameters are A, B and N. Then range, that is 0, which is minimum. A and N, among A and N, which is minimum, that is a range. And probability mass function ACX, BC n minus x by A plus B, C, N. That is a probability mass function where x is equal to 0, 1, 2, minimum, open the bracket, A, comma, N. And mainly these three formulas. Mean is equal to NA by A plus B, variance NAB into A plus B minus N divided by A plus B whole square into A plus B minus 1. Now, nextly, we will see the problem under hypergeometric distribution. Now, we will discuss first problem in case of hypergeometric distribution. Now, read the problem there. A basket has 10 mangoes, out of which 6 are ripe, 3 mangoes are randomly selected. Find expected number of first one, ripe mangoes among the picked ones, and second one, probability that all the picked mangoes are ripe. A basket has 10 mangoes. The total there are 10 mangoes. Out of that, how many we selected? 6 we selected and 3 mangoes are randomly selected. So, in front of us, we have 3 numbers, 10, 3, 6 and 3. Now, the random, 3 mangoes are randomly selected. We know that random selection is nothing but N. So, 3 is N then. The random selection, what we select, it will be always a sample selection, what we selected, that is a number, always the sample number, that is N. Then what is this? 6 and 10. And a basket has 10 mangoes. We know that total there are 10 mangoes. The 10 is A plus 1. The total number will be, most of the time you will be giving total number. From that you have to identify which is A and which is B. Now, in order to find out A and B, you have to see the question. Now, question is about ripe mangoes. Here, the number of ripe mangoes, and here also the question is about ripe. The question is about ripe. So, what they will ask in the question it means about what? The question is about what? Question is about ripe mangoes. Question is about ripe mangoes. So that will be always A. Ripe mangoes will be always A, and what is remaining, that is B. Now we have to find, we know that question is about ripe. Now we have to find in the question whether they have given the number of ripe mangoes or they have given the number which is not ripe. What number they have given, whether ripe number or which is not ripe. They have given the number of ripe mangoes. So what is that? 6. 6 is A. 6 is A. And what is the number of B? Out of 10, if 6 are right, how many are remaining? 4 are remaining, that is B, which is not right. For example, in the same question, they have questioned about ripe mangoes, but here this number they have not given about ripe. They have assumed that out of which 6 are not ripe. They have given out of which 6 are not ripe. 6 are not ripe means how many are ripe then? 4 are ripe. In that case 4 will be A. In that case 4 will be A, 6 will be B. Now mainly we have to see in the question what they have given in the question. Question is about ripe mangoes. So what will be there in the question, that is A. What will be there in the question, that is A. The A is ripe mangoes here. So whether we have to find whether they have given the number of ripe or non-ripe. They have given the number of ripe only. So that is A. So here A is 6 and B is remaining 1, 4 and A plus B is 10, N is 3. First we will try what is given here. Now solution. Given A plus B is 10 and A is equal to 6, B is equal to 4 and N is equal to 3. And yes, what they have asked, number of ripe mangoes among the selection of 3 or else the selection of 3 mangoes in a number of ripe mangoes in the selection of 3. Next right there, probability mass function. What is probability mass function there? P of x is equal to ACx into BCn minus x divided by A plus BCn, where x is equal to 0, 1, 2, minimum A comma n. Next, according to this particular problem, write the probability mass function. What is A here? A is 6. 6Cx. What is B? 4. 4Cn we know 3. 3 minus x divided by A plus B. A plus B is 10. 10Cn. N is 3. And x. What is A here? A is 6. What is N here? N is 3. Which is minimum? A or N, which is minimum. N is minimum. Number of N is 3. So 0, 1, 2, 3. This is the range. Then come to the question. Now, what is that first question? They have not asked any probability or at least more than, less than 2, more than 2, at least 2 or 3 or more. Such kind of questions are not there. They have asked expected number of ripe mangoes. See, always expected number. Expected is nothing but mean. Expected number means it is nothing but mean. Remember, expected number means mean. We have to find out the average. Second question, as it is probability that all the picked mangoes are ripe. All picked mangoes means how many mangoes we picked there? 3 mangoes. Means P of 3. All picked mangoes. 3 also we consider as ripe mangoes. P of 3 according to second question. First question we need to find out mean. What is the formula for mean there? Your mean formula is equal to NA divided by A plus B. Now according to this question, what is N? N is 3 and what is A? A is 6 divided by A plus B is 10. So here 18 by 10 we get here 1.8. So mean is 1.8 there. Second question, move to second question. The probability that all picked mangoes are red. So there, according to second question, we have to take there and write here all picked mangoes. All picked mangoes, that is P of 3. All picked mangoes means P of 3. Probability of all 3 are ripe mangoes. Now, see the probability mass function. 6cx, in the place of x we have to substitute, we need to substitute 3 into 4c, 3 minus x is 3 here, 3 divided by 10c, 3. This is the function. Now here, how to solve this? What do you mean? See, I elaborate since it's the first function. I elaborate here. 6c3 means 6 into 5 into 4 divided by 3 into 2 into 1. This is 6c3 into 4c3 minus 3 is 0. So 4c 0 we consider as 1. Just write 1 here 1 divided by 10c3. 10c3 means 10 into 9 into 8 divided by 3 into 2 into 1. See, I suggest in case of hypergeometric distribution, write like this. You can show this in case of problem in the, or you can do this roughly also. And first you have to solve this right there. This side is your right, this side is your right. Or else you see which will be convenient for you. Now here we will see now here when we solve 6c3 we get there 20 into 1 as it is, no need to write. Now we will solve 10c3 here. Here we get, when we solve 10c3, we get there 120. Simplify this. When we simplify, we get there 1 by 6. Either you can write 1 by 6 or else you can divide it and write 0.667, which will be perfect. I hope it is clear. This problem is actually easy compared to other problem, but where you people will go wrong in the sense, in case of this calculation, 6c3, 3 elements of 6 means we have to move backward. 6, 5, 4 over 3. 3 till 1 till 1. Then 4c, for example 4c2 is there. Then 4 into 3, 2 into 1. I hope it is clear. We have seen this already. So this here with this we completed first problem under hypergeometric distribution. So this is about hypergeometric distribution. Firstly you need to identify A plus B, A, B and M. What will be given in the question, that is A. A is right here. Whether they have given right number? Yes, they have given right number. So A they have given. Which is not right, that is B. Then out of 10, if 6 are right, 4 are not right. So enough for today. We solved what we have seen. What is hypergeometric distribution? Then we have seen the features of hypergeometric distribution and we discussed one problem. Now in further classes we will discuss further problems, then you will be clear about hypergeometric distribution. With this we will wind up with today's class.